Today, you're going to learn how to unlock real-time and predictive insights from your Internet of Things. I'm Santosh Balasubramanian. I'm a program manager in Azure Stream Analytics. You're going to learn a lot more about it today. All right, so let's start with a customer scenario. Imagine you're a manufacturing firm. You have robots like this, and you have things which are actually going on your factory floor. These objects are actually generating sensor data, millions of sensor data points. What do you want to do with it? What kind of insights you want to get with them? Here are a few of them we have heard from customers. I want to be able to monitor in real time what is the status of my factory floor. I want to be able to get alerts in case something wrong happens. I want to be able to do predictive maintenance. It's not just about those machines which are failing right now, but which machines have the highest probability to fail. I want to be able to do forecasting of the energy which is being used by this plant. And not only do I want to take alerts, take an action on the alerts, but I also want to automate action on the alerts. These are some of the subsets of things that people want to do from data which is coming from sensors, from the IoT devices. And today I'm going to walk through showing how on Azure you'll be able to do a few of these things. Now we have talked about a factory floor end-to-end scenario. Let's talk about what is data in motion, what we are talking about today. So there is data which is being generated from a variety of different places, continuously being generated. There are things from social media like your Facebook or Twitter or other places, or from devices. You have your mobile devices which is continuously generating data. There are sensors all around us which is generating data. Actually, let me show you an example. Here, what I have here is a weather shield which is connected to an Arduino Uno board and connected to a Raspberry Pi device. This Raspberry Pi device is sending data, the live temperature, live humidity, how much is the light which is here, all of this from this room currently where we are recording to Azure. And let me actually prove it to you. As I told you, this is live. As I'm blowing or I'm actually holding this particular thing, you can see the temperature went up from 75 to 81 degrees. The humidity went up when I blew onto this. And the light, check this out. I'm covering this and immediately the light drops. Sensors like this is what I'm talking about, which is sending the data continuously. Let me start with some customer stories. What Honeywell is trying to do is Honeywell is trying to build a building monitoring solution. So in any of the buildings that we are in, we have a bunch of different sensors. We have temperature sensors, we have CO2 sensors. What Honeywell is trying to do is they're trying to provide solutions so that their customers are able to monitor buildings correctly. In case the temperature spikes in certain areas, in case there are CO2 spikes in certain areas, how do I know about that immediately and I can kick off a workflow? I can kick off an action that can happen from there. Then let me go to another completely different use case, Fujitsu. What Fujitsu is doing is they basically took a factory floor and they said, let us try to innovate on this. So I don't know if you realize this, but for certain kinds of diseases, you have to control the amount of potassium which is there in your diet. What the researchers at Fujitsu found out is how can I monitor the environment, the temperature, the humidity, the soil conditions, and things like that in order to control the amount of potassium which is there in the lettuce that is grown in these factories. So they have all of these sensors which is monitoring this factory floor which is growing this lettuce, and once they collect the data from these sensors, then they're taking some real-time insights, some predictive insights, and taking actions in case something wrong happens with the environment. So another example I want to talk to you is about ThyssenKrupp. So many of the elevators around here are from ThyssenKrupp. What ThyssenKrupp has is they have vibration sensors and a variety of other sensors which are these in these elevators. How they want to optimize their workflow is not just those elevators which are broken right now, but which elevators have the highest probability of having issues. How can I optimize my workflow by predicting issues which are happening by collecting the data from these sensors? So why I'm showing you these slightly different customer scenarios, and there are tons more like this, is the the talk today is going to go around how can I use Azure and Microsoft services in order to help build solutions and fix the problems that customers are asking about. So let me actually walk through how I'm going to talk through this session. So say you have the factory floor. The first thing you want to do is ingress the data. Then I might want to look at what is the current health of the service, of the things which I have in my factory floor. So I'll have my live dashboards, I might have alerting based on issues which are happening, and then we will go towards the predictive maintenance concepts. So let's start with ingressing of sensor data. To ingress sensor data into the system, I'll talk about two services, and I'll also show you these in some of the demos going ahead. The first service is called Event Hub. Now, Event Hub is a service, a highly scalable publish-subscribe service to which I can connect millions of my sensors, services, and send data from all of these sensors. So this is for sending the data. And once I send this data, there are some retention policies, and I can have readers and other things which can do analytics on top of it. The next service that I want to talk about is this is our IoT service, which is the Azure IoT Hub. With this, not only can I send my sensor data, but I can also do bidirectional communication. I can actually send commands back to the devices as well. I can have device management in it. So there are security aspects with my devices that I can care about. So if I have my factory floor, if I have all of these sensors around, and I want to be able to manage these, I want to be able to collect the data, or I want to send some commands back. For example, if the temperature spikes more than something, I want to be able to turn down the thermostat. That's exactly where you want to use a service like IoT Hub. So now that I've talked about how to ingress the data, the next step that I want to talk about is the scenarios which we had mentioned, some of the subset of the scenarios. I want to be able to see a live dashboard with the live status of what is happening on my factory floor. I want to be able to do alerts, and I want to be able to put some logic based on which I can kick off workflows or take actions. So for this, I'm going to talk about a service called Azure Stream Analytics. Before I do the Azure Stream Analytics, the first thing that I want to do, just to give you a little more context, because this is going to be more and more interesting, is I talked about all the devices or applications which is sending data. I talked about event hubs and IoT hubs for bidirectional communication with all of your devices. Then you want something which will do your processing logic. The insights that you're trying to get, how can I define that logic on the insights? That is fundamentally the Stream Analytics service that I'll mention. How do I get the real-time insights from this data? How can I actually not only put threshold-based insights or other things, but how can I actually work with machine learning models on this data which is coming in real time and get insights, and then push out results to a variety of different services or variety of different areas based on your use case. For example, I will show you today, if I am getting data from sensors, how do I actually use Stream Analytics in order to do live dashboarding with something called Power BI? I will show you how I can take alerts. If I want to do alerting and taking actions, I can do things like pushing the data back into event hubs or service bus queues and topics, and then listen to those events in order to create, either send commands back or take an action on those commands, kick off a workflow. I can also take the data, enrich the data, and archive it in order to do post-processing. So in the predictive maintenance scenario, I'm going to show you that as well. I can push the data to things like SQL DB, blob stores, table stores, document DB, Azure Data Lake, and a bunch of other places where I can do some of my cold path analysis. So let me talk about Stream Analytics, because that is the first part where I can do my real-time insights. Stream Analytics is a fully managed real-time analytics solution which allows you to do your complex event processing. So all of these millions of sensors which are connecting to my IoT hub, which are sending the data, now I want to do something such as, I want to do some aggregation. I want to know for this particular building, what is my average temperature from all the rooms which are actually having my temperature sensor. Or I want to take an action if any one of those rooms spike. For this, you need a system which is able to get the real-time data, do temporal analytics on top of it, and is able to give you those insights. This is where we came out with Azure Stream Analytics. It is fully managed. What does fully managed mean? You don't have to set it up. Everything is set up. It is easy to scale. It has built-in checkpointing, so fastest recovery that you can. You can do things like ordering, reordering of events. You can actually do temporal logic on top of it, and I'll show you what I mean by the temporal logic as well. But one of the more interesting things is, I'm sure you can use a variety of different ways to do this. I can write Java code, I can write .NET code in order to do this. But what we have done is, apart from taking off all those manageability, your high SLAs that you get on a service, we have also given a SQL-like language on top of the service through which you can do your stream processing. And that is something which, when customers talk to us, has fundamentally improved the developer productivity. So what do I mean by the SQL-like language? If you know SQL, at this point, you can do your stream processing. Selects, from, group by. I can join multiple streams together. I'll actually talk about that later as well. I can scale using things like partition by. I have all of my date time functions, because if you're dealing with a lot of stream processing, if you're dealing with data which is in motion from sensors, events, the temporal processing is a fundamental aspect for it. I have a bunch of mathematical functions, things like square root, power, and things. I have temporal functions. I can get windowing extensions. So this is very interesting. I can actually define what is the window in which I want to do my logic in a SQL-like language, and all the other things which you can do in SQL, like sums, counts, standard deviations, string functions. So why I'm mentioning this is you will fundamentally understand how we have simplified the concept of writing your logic, which will extract those insights, and also tying it to other services, which will enable you to create your end-to-end workflows. So now let's jump into the demo. So in this demo, just like what we showed you with the weather shield, I am going to simulate that same data with an application. I've just written some custom application, which is simulating similar data. It is showing the temperature, the humidity, when it was being sent, and you can see these temperatures are moving. What is the name of the sensor? This payload is actually being sent to Event Hub. From here, I need to be able to do things such as show this live dashboard. I want to get alert if the temperature goes over 75 degrees for some amount of time. For that, you need to use Azure Stream Analytics, the service that I was talking about. How I use it? This is all I need to do. I need to click on this plus button, click create for Stream Analytics, write what is the name of my job. Once I do that, that's it. My job is provisioned. Now I need to start doing things with my job. So here is a job I'm going to, just for test purposes to show you. I click on it. I have to add the inputs. This is the ingress from where my streaming data is coming into the picture. So I click on this. I can add multiple inputs. I want to have a continuous sequence of data. So this is where I can add my event hubs. I can actually even have data in blobs which I can stream, or my IoT hub. Once I select it, I need to give some name. This is the alias from which I can access it. So I can say something like stream input. If my event hub or IoT hub is in the same subscription, we automatically populate it, and you just select what it is. Press next. What is the serialization format? Here we are sending JSON payloads, and click OK. That is all I need to do to set up data coming in to my stream processing pipeline. Then I set up my output. In my output, I can add a multiple set of outputs. I can output to a SQL database, blob store, table store, document DB, data lake, Azure Data Lake for archiving my data. I can do things such as for live dashboarding, pushing my data to Power BI. I can actually get notifications, or if I want to kick off workflows, use service bus queue, service bus topics. I can select a multitude of these while creating my logic. For this purposes, because I'll start with the live dashboard, I'll just select Power BI. I click authorize myself. Once I authorize myself to Power BI, my output is created, and that's what I'm going to show you. I've already created this in another scenario. So here, my Scott demo ASA, that's what I have called my demo. I have already created my Event Hub input. I said I want to create my output, which is Power BI. I say what is the name of the data set, what is the table name, and then my query. So I'm just taking the data, finding the maximum humidity, the maximum temperature in a 1 second window, and I'm pushing it out to Power BI. This is all the logic that I need to write. So instead of this one simulated sensor which is coming, imagine if I had 1 million sensors and I want to get the max temp, max humidity over a second from all of my sensors. This is all I need to do. Select maximum temperature, maximum humidity, give a name to these columns. Just a bunch of other things that I'm doing. I can actually say what time, when the time is being written, the system time, from my input into the alias of my output, where the display name is equal to, in this case, just because it's a demo, I'm saying it's for a particular sensor. But then I can group by a tumbling window of 1 second. So every second, all of these sensors, which have the name TI sensor tag B, are going to give the result of what is the maximum temperature within the second, and write this result every second to the Power BI dashboard. That was how simple it is to go directly from here to the dashboard and not having to write any other logic but this SQL logic and selecting some configurations. But it's not just about seeing the live status, right? I want to be able to do things such as get some alerts. So in my particular scenario, I'm going to simulate a spike. So I'm just going to click on this, and you basically see when I'm clicking on this, a bunch of things are happening. The temperature is increasing. You can see here the temperature had gone up to 79 degrees. And when I did that, you're seeing some of these live threshold-based alerts just came up. And just to map it on to when I was actually doing the spikes, you saw there was a spike that I did at 11:36. That same threshold-based alert came up at 11:36 because my temperature went over 75 degrees. So let me show, how do I show the logic for this? So for this, I have another job that I have created. This job is also reading from that same event hub. And this is what the job is doing. It is basically saying, whenever the average temperature in a 5-second window is greater than 75 degrees, then I want to create an alert. So I am again going and saying DSPL as a sensor name I want to write for the alert. I want to take the average temperature at this time. I want to use the time which was generated in the sensor. This is a very important thing in stream processing. I can either use the time when the event arrives to the stream processing solution, or I can use the time which is generated at that sensor. In order to do that, we just use timestamp by time when the tumbling window of 5 seconds. So if the average temperature in this window of 5 seconds is greater than 75 degrees, that is when you get this alert. So I hope what I have shown you is how easy it is to go from your sensor data, do your processing logic on top of this in a simple SQL-like language, and get the results from that, be it a live dashboard or threshold-based alerts or any of the other things. And you can use the richness of everything that I showed you in that SQL language in order to create your logic. You can also connect this to machine learning models. So I can do things such as go to my functions tab, and if I had a machine learning model in here, sorry, I cannot do this while the job is running, but I can do this in another job which is not started. I can add a machine learning model. I can give it an alias. Let me say something like anomaly detection. And now I can basically point it to the endpoint of the machine learning model and use anomaly detection like a user-defined function in my SQL-like language. The last thing that I wanted to show you is how do I scale this. We have a concept of streaming units. Streaming units is the amount of compute power that you want to give to your job, your logic. You can go from 1 to 40, and you can also ask for more streaming units. What we do is we basically say, we throttle you at 1 megabyte per second in a streaming unit, the amount of power that you're given. What happens is, if you have some very complex logic where you have a big temporal window where you need more compute resources, you might actually get throttled less than 1 megabyte per second. And all you need to do is go and say, how many more streaming units do you need in order to give more compute power to your job? You also have things such as, how do I reorder my events? So you don't have to write any logic, because from these devices that we are talking about, events can come at completely different times, right? Can arrive, and I want to be able to reorder it using policies. If some event comes after my policy, what do I want to do with it? So there's a bunch of configuration settings that you can use to create your logic as well. So now that you have seen how easily I can create my end-to-end pipeline for getting my live dashboards and alerts, let me talk to you a little more about stream analytics. So we showed you some of the windowing functions where you have the tumbling windows where I want to get some insights. Every 5 seconds, I want the average temperature. So every 5 seconds, you'll get the results of those millions of sensors, the average is done and given out to you. I want to have things like hopping windows. So I want to be able to say, I want the average temperature every 5 seconds, but I want a result every second. I have things like sliding windows where it only gets kicked off when an event enters or leaves the window. I can do things like join multiple streams together. So if I have data coming from my temperature sensors, I have data coming from my CO2 sensors, and I want to correlate them, I'll be able to do this. I can find patterns in events and the lack of patterns, the absence of events. I can use things like joins, inner joins and left outer joins to do this. One very interesting thing that you can do is also, when you're thinking of streaming data, it is not just about data in motion. It's also about data at rest. A good example, which we have always heard, is the data which is coming from these sensors. They're very small payloads. They will probably have the ID of the sensor and a key value pair. But you want to be able to say, how do I map these things? This is all in a static file. That is what we call reference data. So I can join my static file with my data in motion and then do my logic on top of it, just like I had shown you the logic there. I can scale. So we have the concept of scaling. I can use partition by keys, and I can actually scale out my workloads to do parallel processing in this as well. Now, I can not only have a single input, but multiple inputs, and write that logic into multiple outputs. I actually showed you that in a demo, and have multiple steps where I can define different parts of my logic. Apart from all the things that I've mentioned, with the fact that you have a fully managed service, it spins up automatically, you have checkpointing which is built into that, you can reorder the events. One of the main things that we focused on Stream Analytics, because we realized when we were starting to work with customers that the amount of data which is pushed depends on the types of the customers. So really you can have low throughput but continuously moving data workloads to very, very high throughput workloads. In scaling, we can go all the way from 0 to a gigabyte per second, and you actually pay for only what you use. So if I am pushing 1 megabyte per second through the one streaming unit, which I had shown you in my demo, which is the amount of compute that you get, for the whole month pushing 1 megabyte per second continuously and doing some processing on top of it, you'll pay not more than $25. And this is because we have built a multi-tenant solution. If you have more throughput which is coming through the system, then I can just increase the number of SUs. If I need more processing power, I can increase the number of SUs. But this really depends on what is the scale of data which is coming through your system. So this is not only built for the high scale with the partitioning, but this also built for the cloud efficiencies, paying less amount of money for the low throughput workloads. All right, now that I showed you how to do real-time analytics, how to do dashboarding, and how you can use Azure Stream Analytics and IoT Hub and other services to do it, I'm going to talk about a different scenario. I want to be able to predict what is the next thing that I need to go fix. I want to be able to predict which of my issues are going, which of my devices or machines are going to get spoiled next, or which have the highest risk of getting into issues. What is the lifetime which is left in my devices? In order to do this, you want to be able to collect the data and run machine learning models on top of it, and then get the results in some form that I can go back to my service engineers to do it. Let me jump into the demo for this. And before I show you the demo, I'm going to show you one more slide, okay? In this slide, what I'm going to show you is we are going to simulate aircraft engine data which is coming in real time. By the way, this is data that we have collected or got from NASA, and then I'm going to take the data, I'm going to stream the data in real time, I'm going to simulate the data, but I'm going to stream it in real time. I'm going to do analytics on top of it to show the live status of my aircraft engines. At the same time, I'm also going to run machine learning models on top of it and show the results of it in my same dashboard. So me as the service engineer can just sit in front of one dashboard and not only see what is the current status and the real-time status, but also what is the status of issues that might happen in the future. So now let's jump into the demo that you have a little bit of context about this. What I'm showing you here is the aircraft engine data which I had talked about. What we got is we got some aircraft engine data from NASA which we are simulating and sending in real time. Once this data comes through the system, you can see, me as a service engineer can see a bunch of things, things like information about particular sensors, number of alerts which are being done by a sensor. But the more interesting thing that I wanted to show you, and I'm actually going to zoom into this, is predicted remaining useful life. So now, not only am I seeing what are the issues and alerts happening now, but me as a service engineer can say, this engine 66, I need to be worried about this because this has the least useful life for this. So how do I do this? I take the data from the sensors through IoT Hub or Event Hub. I archive it from Stream Analytics to a SQL database. So the next thing I will have to do is create a machine learning model which does my predictive maintenance. For this, I'm going to what we call the Azure Machine Learning Studio. This is where my data scientists can go and do things such as take the data, and as soon as this loads, actually I'm loading the model that has been created by my colleague Danielle Dean, who's the data scientist here. She has taken the aircraft data, she's executing some R scripts. Let me go up on this so you can actually just look at one particular chain of execution that she has created. I can write my R code in here. I can use some of the existing things such as some of the statistical functions which are available here. I can insert R modules, I can insert Python modules. So me as a data scientist, I can do a bunch of things here, drag and drop or write my own custom code. Once I have trained my model, then I can also test my model and validate it with certain subsets of data. And then now that my model has been created, and you can see this is not something small, this is actually a pretty interestingly complex model that she has created. I want to be able to operationalize it. So for that, I just go and say, set up my web service and click on this predictive web service. Once I click on this, what happens is now I get an operationalized model. And here it automatically goes, it creates this, where I get a web service endpoint and a web service output, and everything that I have done, such as the scoring of the model, is now being taken care of this operationalized model. And in order to access the web service endpoint, I can basically go here to web services. Here is exactly the model. I can do things such as see what is my API key. I can test this model. I can do batch execution as well as request response. So for the real-time nature, which I had shown you earlier, I can go and do this. So now that my model has been created, I want to operationalize it over that aircraft data which is there in the SQL database. For that, I use a service called Azure Data Factory. So here is Azure Data Factory. I am going to open up the data factory that I have created in order to operationalize this particular model or use this model for my end-to-end use case. I'm going to click in the diagram and talk about this a little bit. So what is Azure Data Factory? Azure Data Factory is a service that not only helps you create, but also orchestrate my big data pipeline. I can monitor my big data pipeline. So in this case, I have created a whole pipeline which reads data from my SQL database. It actually cleanses the data, puts it in the blob store. Then I can call my machine learning model using this activity. The results of my machine learning model is pushed to another SQL Server database from where I am pulling through this Power BI dashboard. So that is how simple it is, where Azure services can help you bring that data, store the data, create your machine learning model. Then we have services which help you orchestrate and create the big data pipeline to do batch analytics on top of it, push it back in storage, and show this in a BI dashboard. All right, so now I hope what you understand is how you can do your predictive analytics on data which is coming from your sensors, your Internet of Things, using all the services on Azure. It could be Event Hubs, IoT Hubs, Stream Analytics, Azure ML, Power BI, ADF, and a bunch of different services that actually help you create your end-to-end solution. Based on this, thank you again. I hope you have learned how I can actually take my whole scenario of my factory floor and I can enable parts of it easily using everything that I have shown you today in the demos as well as the presentation. Thank you.